I'm going to begin here by solving some simple quadratic equations. And by simple, what I mean is any quadratic that we can solve using only inverse operations. In other words, we don't have to go through and look at any other methods such as factoring or the quadratic formula. An easy way to pick out these problems is to look at any sort of quadratic equation, such as 4x squared minus 3 equals negative 19. And notice that there's only one set of x's in my problem. There's only one variable term right here. So my goal is to go through and use inverse operations in order to isolate that variable term first. So I start to unpeel these layers like I do with any other equation. My first step would be to add 3 to both sides, which leaves me with 4x squared equals negative 16. And I keep unpeeling these layers around the x squared. Get rid of this 4, and I end up with x squared equals negative 4. So the question is now, how do I undo a squared? And I think about my inverse operations. I know that the inverse operation of squared is square root, but I have to be careful. When I introduce a square root to a problem, I have to put the plus or minus on the right-hand side. That's what gives me my 2 answers for my quadratic. So now all I have to do is simplify my answer. On the left, I get the x. On the right, I remember, do a little scratch work over here, that the square root of negative 4 is really an imaginary number because the negative underneath is the I, and the square root of 4 is 2. So if I have plus or minus the square root of negative 4, I really have plus or minus 2i. And that's my final answer right there. I have my 2 solutions to that quadratic. And in this case, my 2 solutions are imaginary numbers. For a second example, a little bit more complicated. There's more layers to unpeel in this one. I have 3 times x minus 6 quantity squared plus 1 equals 55. So I look for the variable term, the piece that I want to get by itself. Right there it is. So my first step is to undo these 2 layers. I subtract the 1, and then I'm going to divide by the 3. So when I subtract the 1, I get 3 times x minus 6 squared equals 54. Divide by the 3, I get x minus 6 squared equals 18. Keep using inverse operations. What undoes a squared? Well, square root. And I square root both sides and add the plus or minus, so I get my 2 solutions. So on the left, I get x minus 6. On the right, let's do a little scratch work again. I know that root 18 is really the same thing as the square root of 2 times 3 times 3 if I do a factor tree. So then I can pull that 3 out. So I really have 3 square roots of 2, which is equivalent to root 18. It's just reduced. So I'm going to replace this right-hand side with plus or minus 3 root 2. And I have to keep using inverse operations. The last thing I want to get rid of is this negative 6 right here. Now I'm going to take him over using inverse operations, so I'm going to add him, and I'm going to put him in front of that plus or minus. So on the left-hand side, I get the x. On the right-hand side, I put the positive 6 first, and then plus or minus 3 root 2. And the gut reaction for some people is to go ahead and add the 6 and the 3, but you can't do that, because if you do, you're adding a regular rational number with an irrational root 2, which is not a good thing. They're not like terms. So this is my final answer, 6 plus 3 root 2 and 6 minus 3 root 2. So when I'm solving any sort of simple quadratic where there's only one set of x's, only one variable term, I can simply use inverse operations the whole way like we always have, introduce a plus or minus, and get both of my solutions.